students, this is Mrs. Bettis here with part 1 of this lesson on graphing rational functions. Let's go. Tips for today are this. I can graph a rational function. I can identify the domain and range for a rational function. And I can identify the asymptotes for a rational function. First of all, a rational function is defined as a function in the form of y equals p of x divided by q of x, where p of x and q of x are polynomials. So in other words, a rational function is just a fraction built with polynomials, or the ratio of polynomials. What we're going to do now is we're going to graph the parent rational function. And our simplest rational function that we could ever create is 1 over x. Notice how x is in the denominator of this fraction. So let's fill in our table. We're going to go ahead and fill in our table. And again, we have 1 over x as our function. So this would be negative 1 over 4. This would be negative 1 over 3. This would be negative 1/2. This is negative 1. If I take 1 over a half, that actually gives me negative 2. This is 1 over 0. 1 over 0 is not allowed, so that is undefined. Again, we have a half, so that's just going to be 2. This is going to be 1. This will be 1/2, 1/3, and 1/4. So now we're going to go ahead and graph these points or plot these points on our x and y axis here. So, all right. So we have at negative 4, my value is negative 1/4. So, I mean, without actual grid lines, it's just somewhere really close to 0. So this is negative 1, 2, 3, and 4. So somewhere close to 0, but it's negative. So it's about here. And then we have negative 1/3. So that's just a little bit farther away. Then we have negative 1/2, and I am just doing the best I can with this little tool here that I have. And at half, actually a negative half, I am down at negative 2. So look at what's happening here. Okay, so then when I get to 0, it's undefined. So I can't graph that. So I'll skip past 0. When I am at positive half, I am at positive 2. When I am at 1, I'm at 1. And then I am at a positive half, a positive third, and then a positive 1/4. So what this has created for us is a graph that actually has 2 branches. And I'm going to do my best here to draw them in. There's one branch. And here is the other branch. Whew. This graph is called a hyperbola. Okay, and it has these branches in it. Now, this particular parent function has 2 branches, but as you will find out later on, our rational function graphs actually could have several branches. And like I said, we'll talk more about that later on. But also important to note is that this graph has some locations where the graph is not defined. And these locations are our asymptotes. And you have on your notes there, it says that the graph features asymptotes, and an asymptote is a line that the graph approaches, but it never touches. So I'm going to highlight our asymptotes here. So the first one we have is right down the center here. This is a vertical asymptote. Notice that at the value of 0, our function is undefined. So that creates for us a vertical asymptote. But we also have a horizontal asymptote here at x as well. So we have 2 asymptotes created with our rational function graph. So again, this is the vertical asymptote. And a vertical line, if you remember, vertical lines have equations that are x equals something. And in this case, this is x equals 0, goes through the x-axis at the position of 0. And we also have horizontal asymptote. Excuse me. And for this one, our horizontal asymptote is going to be y equals 0. So there you have it. This is the graph of our parent rational function y equals 1 over x. If you understand the development of the asymptotes, the positioning of the asymptotes, and the placement of the branches, you really have all that you need in order to understand the rest of this lesson. One last thing that we want to point out about this graph and the positioning of the asymptotes is how it defines our domain and range for the rational parent function. So let me change my color here. So domain, remember, are all of the x values that we could put are that where this function is defined. And our domain is going to be the set of all x values such that x does not equal 0. Because remember, I can't have x equal 0 because it creates an asymptote. I have a place where the graph is not defined. Likewise, my range for this graph, and I'm looking at all of my output values this time, as I travel down this graph, looks like I have values everywhere except, so the set of all y values, such that y does not equal 0. Okay, so domain and range, vertical and horizontal asymptotes. Introducing to you all the graph of the hyperbola, which is our parent rational function graph, which is how do we transform a rational function? And this is very exciting to me because the way you transform any function is similar, all right? You can transform functions in the same ways. So like we transformed y equals x squared into y equals a x minus h squared plus k. Do you remember that? I hope you do. Please tell me that you do. So what we learned when we were transforming this function is going to be the same thing that occurs when we transform our rational function. So 1 over x. So this is the parent. This was our quadratic parent. And this was our fully transformed quadratic. And this is our fully transformed rational. And guess what? The h and the k and the variable a all are responsible for the same things. So isn't that exciting? I think that's exciting. All right, well, let's get into this. Okay. So I may leave this up here for a minute because I want to talk about this one more time. So just to remind ourselves, our original quadratic function was x squared. It created for us, what's the name of this? Parabola, I hope you said. And the a value controlled the vertical stretching or shrinking for this curve. The h controlled the horizontal translation, so left or right movement for h. And because that was negative, it was always in the opposite direction of what you would think. And lastly, we had k, which controlled vertical translation for the curve. Well, guess what? If you understand the job of h and k and a, then those jobs have not changed for this rational function. So let's get into how this is going to make things change for us. So let me erase all of this. All right, and let's get into what's happening here. So first of all, the a value here controls still our vertical stretching or shrinking. So the absolute value of a will tell you how much your curve will stretch or shrink. Well, what does that mean for a rational function? I'll go ahead and just draw this here. All right, so this is our parent, hyperbola. And if I talk about stretching or shrinking of this curve, it really just only controls how close to 0, 0 the curve will be. So I could come in tighter I can try. Or I could be way out here. Okay, so that's your stretching and shrinking as it relates to changing the value of A. Okay, so A controls our vertical, stretch, or shrink. Okay, so we probably won't deal much with that because it is difficult to get accurate graphs when you are just making sketches of rational functions. Okay, so don't get too involved or, too worked up about what A does to our graph. And I need to put that back. Okay, so the next thing that we could do with A, besides change it from a 1, is we could make it positive or negative. So I need you to understand that if my A actually happens to be negative or less than 0, what will happen to my graph is that my graph will reflect. Okay, and the reflection that I'm talking about is my branches will no longer be located in the first and third quadrants. My branches are now going to be located in the second and fourth quadrant. So this is the reflection that occurs if my A value is less than 0. All right, that is the job of A. Let's move on to the other variables. Let's talk about K. I am controlling vertical translation. All right. And just like before, if my K value is less than 0, then I'm going to move down. And if my K is greater than 0 or positive, then I'm going to move up. All right. That's the job of K. And lastly, we have H. So H here is in charge of my horizontal translation. All right. And if my H is negative, all right, if it's less than 0, then I'm going to translate to the left. And if my H is positive, then I'll translate to the right. Now, please note that because there is this negative already here, what you are going to see in your equation will not represent negatives and positives as we think they would. So here's an example. If I have f of x is equal to 1 over x plus 3, then my h is negative 3, okay? So I see a positive in the equation. However, my h value is actually negative. So it's going to translate to the left when I see a positive. All right, and likewise, if I have 1 over x minus 4, then the h value that I have in this equation is actually a positive 4. That's why it's going to go to the right. So what you see is opposite, just like it was when we were doing our quadratic functions. So there are all of the jobs of our transformation variables. We have h, we have k, and we have a. All right, next we have example 1. It says using the graph of f of x equals 1 over x as a guide. Describe the transformation of each of the graph of each function and identify the location of the vertical and horizontal asymptotes. So here we have 1 over x plus 4 minus 1. So just making sure we understand what we have in this equation. We have that our h value, I see a positive, so that's a negative, right? I have a k that is negative 1. So this graph is going to go to the left, and this graph is also going to go down. So please just make sure that you understand what you are seeing in your equation. So this center point are the location of my asymptotes. is going to move over 4 and down 1. So this is now like my new 0, 0. This is the location of my asymptotes. There's the vertical one. Here's a horizontal one. And to make your curve, you are just going to do a general sketch. All right, we'll just make a sketch. Okay, so our transformation is that we moved left 4, we went down 1, and our asymptotes, we have vertical asymptote at, and remember vertical goes through the x-axis, so vertical asymptote is at x equals -4, and my horizontal asymptote is now located at y equals -1. Do those numbers seem familiar to you? Maybe. All right. Last thing we need to do is domain and range. So our domain is the set of all x such that x does not equal, well, what value did I have to leave out of my x? Well, it looks like -4. And if you look at the equation, well, look at that. Remember when we were finding excluded values, and the excluded values came from the denominator? So x cannot equal -4 because that will give us a denominator that is a 0. Our range is y, all y values, such that y does not equal, well, what do we need to leave out for the y's? Well, it looks like we need to leave out -1. Again, do these numbers seem familiar? All right. So there you have it. We have created a sketch. We have explained the transformation. We've given the locations of our asymptotes, and we've given domain and range. I want you to try that for this problem B. Okay, pause the video. Question B, how did you do? Take a look. Make sure that your H and K values are correctly identified. Make sure that your vertical asymptote is accurate, horizontal asymptote, domain, and range. Here we have our summary, everything that we've done so far and discovered of rational functions. For a rational function in the form of f of x equals a over x minus h plus k. Here we understand that the graph is a hyperbola. There is a vertical asymptote at the line x equals h. And the domain is the set of all x such that x does not equal whatever that h value is. And lastly, there is a horizontal asymptote that goes through the y-axis at the line y equals k. So whatever that k value is will be the location of our horizontal asymptote. And the range is going to be the set of all y such that y does not equal k. Okay, let's get into these last two. Example 2 asks us to identify the asymptotes, domain, and range of the function and describe the transformation. So everything that we've done before, this is our check for understanding to make sure that you got it. So for this first function, I have an h value of -2. I have a k value of +4. This indicates that I will be going left, and this indicates that I will be going up. So my transformation is left 2 units and up 4 units. That's the transformation. Let's do our domain and range. Our domain is the set of all x such that x does not equal -2. And my range is the set of all y such that y does not equal +4. The location of my asymptotes, vertical asymptote, is going to be x equals -2, and horizontal asymptote, y equals 4. All done. How did you do? So how did you do? I hope that lesson was clear. I hope you understood the objectives, that we can now graph a rational function, we can identify the asymptotes, and describe the transformations. That was only part one. You're going to have lots of practice. Let me know if you have any questions, and good luck.